In this assignment, we will set up the camera and lighting for our game. Our game will be a top-down style game, where we are looking down on the game area from a fixed position above the game. If we switch to the game view, we can see that the camera is in a completely different position from where it needs to be for our game. When we look at the main camera in the scene view, we can see that it is behind the player game object and slightly above it. This is the default starting position for the main camera in a new scene. Unity will always include a default main camera at this position in every new scene. At this point, it's worth noting that in the scene view, when we have a camera selected, we can see a preview for that camera in the lower right of the scene view. So, we want to move the camera to a position above the game area, where it is looking down on the game. Don't forget that the camera is simply a camera component attached to a game object in our scene. We can manipulate the camera in our scene by affecting the camera's transform. First, let's reset the camera's transform by using Reset on the context-sensitive gear menu. This will reset the transform values and set the camera to the origin point with no rotation and a scale of 1. With the camera at origin, let's rotate it to face down by adjusting the rotation on the x-axis to 90 degrees. Next, let's grab the transform by using the transform handles and lift it up along the y-axis. We can see how the camera preview is updating to show what the camera is rendering. For our game, we can simply change the y value to 10, placing the camera 10 units above the player's ship. Now that the camera is in place, let's set up the camera component. The first decision we need to make is about the camera type. Will our projection be perspective or orthographic? Our game needs to feel like an upright arcade game. These did not have any perspective, so we will choose orthographic as our projection mode. When we're using a perspective camera, if we want to change how much of our game the camera sees, we can adjust the field of view value. This is a lot like changing the zoom on a real-world camera. The larger the field of view, the wider the lens, as it were, and the more our camera can see and render. When we are using an orthographic camera, we can adjust how much the camera will see by changing the orthographic size. But what is the correct size for our game? We can see a fairly reasonable representation of the camera in the preview window, but it might be better to do any final adjustments in the game view itself. We will still have control over the component in the inspector, and we can see the actual camera output full size. It seems that the ship feels right when the orthographic size is around 10, so let's set that value to 10 exactly. Now the player is in the exact center of the game area. I feel that the ship should start near the bottom of the screen. What's the best way to do this? We could switch back into the scene view and move the ship by dragging the ship's transform handles, but we have no good feedback from the game view or the camera to know if we have chosen the correct position. We could change our layout so we have both the game and the scene view open at the same time, but we don't need to. Let's switch back to the game view and move the ship while we are able to see it in the full-sized game view window. We will need to move the ship by directly manipulating the ship's transform component. We want to move the ship along the Z-axis, so click on the field title, in this case the Z, and drag back and forth until the ship looks correct in the scene. Now we have a problem. We really want the player's game object to be at origin. We want this for two reasons. One, it just feels better to me. And two, it will make certain steps later on in this project easier to manage. Yet I still want to have the player's ship start down here at the bottom of the game area. Well, as we know, all things are relative. So let's move the camera, not the player. Reset the ship's transform back to origin. And select the main camera. Again, by dragging the field title, move the camera's transform up along the Z-axis until the ship is in a good position. This feels like a good position for the player's ship. Let's clean up the value for the camera's transform Z-axis. A clean round 5 is good. Next, let's set the camera's background. Currently we have the default background found in the clear flag setting. This is Skybox. We won't be using a skybox today. We simply want a black background. So let's change the clear flags to solid color. It's worth noting that if our clear flags is set to skybox, and we have no skybox assigned, clear flags will use the background color instead. This is why, even though we have skybox selected, we see the blue from the background color. Click on the color box. This will bring up a color picker. Let's make our background black. When we are done, we can close the color picker. We have no lights in this scene. Our background is black, yet we can still see our player ship. Why is that? If we go to Edit, Render Settings, we can see a property called Ambient Light. Ambient light is the light from no fixed point that lights all the surfaces in the scene. All new scenes have an ambient light set to 51, 51, 51. So every new scene has a very dim ambient light added to all objects in that scene. These values can be adjusted to add a general color or full white light to all objects in the scene. However, this light has no directionality and it can be very unflattering if used incorrectly. We will set our ambient light to black, effectively turning it off. Now let's light our scene. We will be creating a modified 3-point lighting system for our game, with a main or key light, a fill light, and a rim light. These 3 lights will show off the shapes of our objects and give our game a good sense of atmosphere. Start by selecting Create Directional Light from the Create menu in the Hierarchy view. This will add a directional light to our scene. Rename this game object Main Light. Next, let's reset the light's position. This will set the light to origin. We won't see any change in the lighting, as directional lights light the entire scene based on their rotation, not their position. Switching back to the scene view will show us the light, and the gizmo will show us its orientation in the scene. Let's now reset the rotation as well, so we can have a clean set of values to start from. This is our main light, so it will be the brightest and most important. We need to see the light on the ship from our main camera, which is above the player. So let's tilt the main light down onto the scene, but not too much. We want to see the shape of the ship, but not wash it out. That looks good. It's nearly at 20 degrees, so let's clean up that value to around 20 degrees down into the scene. Now let's rotate the light around on its y-axis and bring the light in from the side. Let's pick a good point towards the front, but not directly in front. It feels good about here. Let's clean up these values to around -115. To see how this light works in our game, let's switch back to the game view. We want the main light to feel like the light from a nearby sun, so let's increase the intensity to 0.75. This gives a nice hot feeling to the right side of the ship. We could change the color, but let's leave the main light at white for now. This lighting might seem realistic for some deep space environment, but the other side of the ship is far too dark for this game. To light this side of the ship, we need another light. This will be our fill light to fill in the shadows on the far side. To build our fill light, duplicate the main light. Make sure the main light is selected, and then use Edit, Duplicate, or use the hotkey combination. Rename the duplicate Fill Light. These 2 lights are now doubling up on the same surfaces as the lights add together. Don't worry, we'll soon change this. First, let's reset the rotation on the fill light, and then switch to the scene view so we can see the gizmo on the light. We could set this light by eye in the game view, but it can also be helpful to see the light's gizmo when making adjustments. Let's grab the fill light and rotate it around on the y-axis. Here we want to light the other side of the ship, also from a direction in front of the ship to complement the key light. This feels good. Let's look at the lighting in the game view. The direction of the fill light looks good, but it's feeling like we now have two main lights. We don't need two main lights, so let's reduce the intensity of the fill light down to 0.5. And let's change the color as well. A hint of blue will tell us that this is a secondary light. Let's reduce the red channel to 128. And then let's also reduce the values of the green and blue channels as well, down to about 192. Generally darkening our fill color. By toggling the fill light, we can see how it's lighting that side of the ship. Lastly, let's tilt down a little into the scene. 5 degrees is enough. And let's clean up the rotation on the y-axis, making it a nice round 125. That looks good. Now, let's add the rim light. Duplicate the fill light and rename it rim light. So we can see our rim light, which will be fairly subtle. Let's turn off the fill light. Now, select the rim light and reset the transform to remove the rotational values. This rim light needs to be fairly clear, and it needs to stand out when mixing in with the fill light, so let's change the color to pure white. Now, we want to light the rear of the ship in a way that complements the fill light. So let's rotate the light around to catch the rear edges of the ship, but on the same side as the fill. This looks good. Let's make this value a clean 65 degrees. This shows the edge well, but it's also acting now like a second fill light. This is mostly due to how much light spills onto the top of the ship. To fix this, let's rotate the light on the x-axis and come up from below. Now, this may seem counterintuitive as we were looking down on the ship, but this will keep the light from shining on the top surface of the ship, and it will still catch the edges that we need to light. Minus 15 degrees seems fine. Lastly, let's drop the intensity down to 0.25. This may seem overly subtle, but when we add the fill light back in, we can see that they add together to give us a good rim light and fill. Now that we've added our lights to the hierarchy, they are sorted alphabetically and mixed in with all of the other game objects. This is not very well organized. If we look into our scene view and select our new lights, the gizmos appear right where we are working on top of our ship in the middle of the scene. Let's add some organization to our scene. We can organize our scene by using empty game objects. Add a new empty game object to the scene using the hotkey. Use Shift-Command-N on the Mac and Shift-Control-N on Windows. Rename this Lighting. Reset the game object's transform. It's important to note this step. When we are using empty game objects to organize our hierarchy, those game objects should be at origin with no rotation and a scale of 1. This can be accomplished by simply resetting the transform component. Now that we've set up our lighting game object, we can drag our lights into it. This organizes our hierarchy and keeps our lights together. To clean up the gizmos at origin, we can move our lighting parent game object up on the y-axis to get it out of the way. Let's move them up by 100 units. Now, there they are, up there out of the way. We can move these lights like this because they are directional lights, and directional lights light the entire scene based on their transform's rotation, not their position. This sets up our camera and our lighting. In the next assignment, we will create a background for our game.